In this video, I'm going to go over some basic problems associated in a typical course of geometry. So what I recommend is that you pause the video and work on each of these multiple choice problems. That's the best way you can learn. So let's start with this one. If the measures of angles ABD and CBD are 5x plus 18 and 7x respectively, which of the following could be the measure of angle ABD? Now we're told that angle ABC is a right angle. So what that means is that angle ABD and angle CBD, they must be complementary. They must add up to 90. So we could say that the measure of angle ABD plus the measure of angle CBD adds up to 90 degrees. Now ABD is equal to 5x plus 18. And CBD, that's 7x. So this has to add up to 90. So let's go ahead and combine like terms. 5x plus 7x is 12x. So we have 12x plus 18 is equal to 90. Now let's subtract both sides by 18. 90 minus 18, that's going to be 72. Now let's divide both sides by 12. 72 divided by 12 is 6. So now we have the value of x. And our goal is to determine the measure of angle ABD. Now we know that angle ABD is equal to 5x plus 18. So now that we have the value of x, all we need to do is plug it in to the equation. So it's going to be 5 times 6 plus 18. 5 times 6 is 30. 30 plus 18 is 48. So this is the measure of angle ABD. It's 48 degrees, which means that C is the right answer. Number 2. C is the midpoint of segment AD. If segment BC is equal to 4 and AD is 24, what is the length of segment AB according to the figure shown below? So we know that AD is 24 units long, and C is the midpoint of AD, which means that CD has to be 12 and AC has to be 12. Now BC is equal to 4. So what is AB? Well, AB has to be the difference between AC and BC. So 12 minus 4 is 8. AB and BC has to add up to AC. So 8 plus 4 is 12. Therefore, this is the answer. C is the right answer choice. AB is equal to 8. Number 3. The measures of angle ABD and CBD are 10x plus 20 and x squared minus 11 respectively, according to the figure shown below. What is the measure of angle CBD? So go ahead and try that problem. So angle ABD, that's given to us, that's 10x plus 20. And angle CBD is equal to x squared minus 11. Now ABC is a straight line. You could assume that if it looks straight. So therefore these two angles have to add up to 180, which means that they're supplementary. So we could say that 10x plus 20 plus x squared minus 11 must equal 180. So let's write this in standard form. X squared plus 10x, and we can combine 20 and negative 11. 20 minus 11 is 9. That's equal to 180. Now let's subtract both sides by 180. So 9 minus 180, that's a negative 171. Now what do you think we need to do to calculate the value of x at this point? We need to find two numbers that multiply to negative 171, but that add to positive 10. We need to factor this expression. Two numbers that multiply to 171 are 9, and 19. Now, for these two numbers to add up to 10, we need to use negative 9 and positive 19. So to factor the expression, it's going to be x minus 9 times x plus 19, which means that if we set each factor equal to 0, if we set x minus 9 equal to 0 and x plus 19 equal to 0, we can see that x can be equal to 9 or negative 19. Now, if x is equal to negative 19, this term, 10x plus 20, or that expression, that's going to have a negative value, which we don't want. So we're going to get rid of that answer. So therefore, x is equal to 9. Now that we have the value of x, we can determine the measure of angle CBD. And we know it's x squared minus 11. So that's going to be 9 squared minus 11. And 9 squared, or 9 times 9, that's 81. 81 minus 11 is 70. So the measure of angle CBD, that's equal to 70 degrees, which means B is the right answer. Number 4. The measures of the three angles of triangle ABC have the ratio 5, 7, 8. What is the difference between the measures of the largest and smallest angle in this triangle? So let's draw a picture first. So let's call this A, B, and C. So the measures of the three angles have the ratio 5, 7, 8. So we can say that this is 5x, 7x, and 8x. Now the three angles of any triangle has to add up to 180. So we could say that 5x plus 7x plus 8x must equal to 180. Now 5 plus 7 is 12, and 12 plus 8 is 20. So 20x is equal to 180. And now we just need to divide both sides by 20. So 180 divided by 20, we can cancel the 0, so it's 18 divided by 2. Therefore, x is equal to 9. Now, the smallest angle is going to be angle A, 5x. So 5 times 9 is 45. So that's the measure of angle A. The largest angle is angle C, which is 8x. And 8 times 9 is 72 degrees. Now the difference between the largest angle and the smallest angle, that's going to be 72 minus 45. And so that comes out to be 27 degrees. And that's the answer, which correlates to answer choice C. Number 5. Point B is the center of the circle. If the circumference of the circle is 20 pi units, then what is the area of the shaded region? Now, since B is the center of the circle, that means that AB and BC represents the radius of the circle. The distance between the center of the circle and any point on a circle is the radius of the circle. So those two are the same. Now we need to calculate r. And we have the circumference, which is 2 pi r. The circumference in this problem is 20 pi. And if we divide both sides by 2 pi, we can get the value of r. On the left side, we can cancel pi. And 20 divided by 2 is 10. So the radius is 10 units long. Now, to calculate the area of the shaded region, you need to realize that it's the difference between the area of the larger object, which is the area of the circle, minus the area of the smaller object, which is the triangle. Now, the area of a circle is pi r squared, and the area of a right triangle is 1/2 base times height. So we already know the radius, it's 10. And the base of the triangle, that's BC, that's 10. And the height of the triangle, which is AB, that's also 10. 10 squared is 100. Half of 10 is 5. And 5 times 10 is 50. So this is the answer. It's 100 pi minus 50 square units. Now, if you want to get the decimal value for that, it's equal to 264.0 1.16 square units. So that's the area of the shaded region. Number 6. What is the area of an equilateral triangle with a side length of 12? So let's draw a picture first. An equilateral triangle is a triangle where all three sides are the same. So in this case, each side is equal to 12. It's also an equal angular triangle where all the angles are the same. So they all have to be 60 degrees because all three angles of a triangle must add up to 180. But we don't need the angle for this particular problem. Now there is a specific formula that you must know to calculate the area of an equilateral triangle. And here it is. It's the square root of 3 over 4 times s squared, where s is the side length of the triangle. So for this problem, it's the square root of 3 over 4 times 12 squared. 12 times 12 is 144. And 144 divided by 4 is 36. So the answer is 36 square root 3, which means A is the right answer choice. Number 7. What is the value of x in degrees in the figure shown below? Now before we start this problem, I want to go over some basics that you need to know. Now we're told that L is parallel to M. So these two lines are parallel to each other. So we can write this symbol to represent that. Now anytime you see this double line, that means that the two lines are parallel. If you see this symbol, it means that the lines are perpendicular, which means that they intersect at right angles. That's a 90-degree angle symbol. So let's say if we have two parallel lines cut by a transversal. Now let's call this 1, 2, 3, 4, 5, 6, 7, 8. Now you need to know that the alternate exterior angles are congruent. So 1 and 8 are alternate exterior angles. They're on the outside or the exterior of the parallel lines and are on alternate sides of the transversal. So 1 and 8 have the same measure. 2 and 7 are also alternate exterior angles, so 2 equals 7. Now the next thing you need to be familiar with are alternate interior angles. So 3 and 6 are alternate interior angles. They're on the interior of the parallel lines, and they still exist on alternate sides of the transversal. 4 and 5 are also alternate interior angles. So angle 4 equals angle 5. Now 4 and 6 are known as same side consecutive interior angles, and they're supplementary. So angle 4 plus angle 6 adds up to 180 degrees. Now angles 3 and 5 are also same side consecutive interior angles. Now 7 and 6 are known as vertical angles, and they're the same. So 7 equals 6, and the measure of angle 5 is equal to angle 8. Now 2 and 3 are vertical angles, and 1 and 4 are also vertical angles. The next type of angle that you need to know is the corresponding angle. So 2 and 6 are corresponding angles. They have the same measure. They're equal to each other. 1 and 5 are corresponding, and 3 corresponds to 7, and 4 corresponds to 8. So those are some things that you want to keep in mind when dealing with parallel lines and transversals. Now let's focus on this particular problem. So these two angles are vertical angles, which means that this one has to be 70 and this has to be 60 because those two are congruent. Now, what do you think this angle is at this point? Notice that these two angles form a straight line, which means that they're supplementary. They add up to 180. 180 minus 70 is 110. So this is 110 degrees, which means this is also 110. And 180 minus 60 is 120. Now these two are corresponding to each other, so this has to be 120, which means this is 120 and this is 60, and these two are vertical angles, so this one has to be 60 as well. Now these two angles are alternate exterior angles, so they're the same, which means this has to be 70, so that's 70, and this is 110, and so forth. So now we can calculate x. Let's focus on the triangle. So this is x, this is 70, and this is 60. Now the three angles of a triangle we know has to add up to 180. So this will help us to calculate the value of x. 70 and 60 adds up to 130. And to calculate x, we need to subtract both sides by 130. So x is going to be 180 minus 130, which is 50 degrees. And that is the answer. So now you had a basic review on alternate interior angles, exterior angles, transversals, parallel lines, and things like that. Let's move on to the next question. By the way, for those of you who want more help in geometry, check out my geometry video playlist on YouTube, and you could find specific topics that you might need help in. So let's finish this problem. How many diagonals does a regular hexagon have? First, let's draw a picture. So here's a regular hexagon, but my picture doesn't look that great, so let's do this one more time. Now, there's a formula that you can use to calculate this answer, and it's n times n minus 3 divided by 2. So this equation tells you the number of diagonals a particular polygon contain. So we have a polygon with 6 sides, so n is 6. So it's going to be 6 times 6 minus 3 divided by 2. 6 minus 3 is 3, and 6 times 3 is 18. 18 divided by 2 is 9. So the answer is 9. Now let's go ahead and show this. So let's start with this side. A diagonal is basically a line that connects one side to the other side. Basically, it connects from one vertex to another vertex. But it can't be like a consecutive vertex, so you can't just draw a line here. That would be a side instead of a diagonal. So this is one diagonal. This is another one. So that's 2 diagonals, and this one is another one, that's 3. Now let's start with this point. So this is a diagonal, that's 4, 5, 6. And then if we start with this point, 7 and 8. And then the last one is from here to here. This would be 9. And that's it. That's all we can draw. We can't draw this one because we already have the blue line. We can't draw that one. We already have a line there. So there's a total of 9 diagonals that we can draw for this particular hexagon. So B is the right answer. Number 9. What is the value of x in the figure shown below? Now, one way you could find the answer is by using the exterior angle theorem, which states that the exterior angle is equal to the sum of the remote interior angles. Now, the interior angles are the angles on the inside of the triangle. So these are interior angles. They're on the inside. The exterior angle is the angle on the outside. So this is an exterior angle. Now, the remote interior angles are the 2 interior angles that are away from this angle. Basically, these 2 angles are the remote interior angles. So they're not connected or associated with this angle. They're far away from it. But they're still on the inside of the triangle, so they're still interior angles. And so the exterior angle is the sum of the remote interior angles. So x is equal to 40 plus 65, which is 105. Now, another way in which you can get the same answer is by calculating the value of angle ACB. Because you know that the 3 angles of a triangle has to add up to 180. So let's call this angle Y. So 40 plus 65 plus Y has to equal 180. So 40 plus 65 is 105. And 180 minus 105 is 75. So that's the measure of angle Y. Now x plus y has to add up to 180 because, as you can see, they form a straight angle. They're supplementary. Now we know that y is 75. So x has to be 180 minus 75, which means x is still 105. So you have two ways in which you can get the same answer, but if you know the exterior angle theorem, you could simply see that x is the sum of the remote interior angles. So therefore E is the right answer. Number 10. What is the measure of each interior angle inside a regular hexagon? So once again, let's draw a picture. Now, a regular hexagon is a hexagon where all sides are the same. So all sides are equal, which means that every interior angle is equal. So we need to calculate the value of x. How can we do so? Well, there is an equation that will tell us the sum of all of the interior angles inside this hexagon. And that equation is this. So S, which will correlate for the sum, is equal to 180 times n minus 2. For a hexagon, n is 6, and 6 minus 2 is 4, and 180 times 4, that's 720 degrees. So that is the sum of all 6 interior angles inside this particular hexagon. So to find the value of each interior angle, we need to take the sum and divide it by the number of sides. So there are 6 sides. 720 divided by 6 is 120. So that is the measure of each interior angle inside a regular hexagon. It's 120 degrees. 11. What is the measure of an exterior angle of a regular pentagon? Well, let's start with a picture. So here is a pentagon, and because we're dealing with a regular pentagon, all sides are the same. Now granted, my picture is not perfect, so you'll just have to make do with it. The exterior angle is the angle on the outside. So in this case, x is the exterior angle. Y is an interior angle. And for a regular pentagon, all the interior angles are the same. Notice that the exterior angle and the interior angle, they add up to 180 because they form a straight angle. They're supplementary. Our goal is to calculate x. Now, the most efficient way to calculate the exterior angle is to take 360 and divide it by n. Now, a pentagon has 5 sides. 1, 2, 3, 4, 5. So we need to divide 360 by 5. And so this will give you 72. So that is the final answer. It's the most simplest way to get to it, which means that B is the right answer. But now, what if you didn't know about this formula? What should you do? Well, first, you can calculate the measure of each exterior angle like we did in the last problem. It's going to be 180 times n minus 2. This will give the sum of all of the interior angles, and then divided by the number of sides, and that will give you the measure of each interior angle inside a regular polygon. So now let's go ahead and plug in n. So n is 5 in this example. Now 5 minus 2 is 3, and 180 times 3 is 540. So then it's going to be 540 divided by 5. Now 500 divided by 5 is 100. 40 divided by 5 is 8. So this is going to be 108. So if y is 108 and x and y are supplementary, x has to be 180 minus 108, which will give us 72. So that's another way in which you can get the same answer. But as you can see, this formula is a lot easier. So B is the right answer in this problem. Number 12. What is the supplement of the angle shown below? So go ahead and try this free response problem. Now we're given the angle in DMS, degrees, minutes, and seconds. To calculate the supplement, we know that 2 supplementary angles add up to 180. So the supplement is going to be 180 minus this particular angle. So how can we subtract 180 by a value in DMS? We need to convert this angle to an angle in degrees, minutes, and seconds. So how can we do that? Well, first we need to borrow 1 degree from 180. So if we borrow 1 degree, it's going to be 179 degrees, and 60 minutes is equal to 1 degree. So it's 179 degrees and 60 minutes. Now we need something with a value in the seconds. So let's borrow a minute. 1 minute is equal to 60 seconds. So it's going to be 59 minutes because we took 1 away, and 60 seconds. So 180 degrees is equal to this value in DMS. Now we can subtract these two values. So first, let's subtract the values in degrees. 179 minus 112 is 67. 59 minus 32 is 27. And 60 minus 45 is 15. So this is the answer in DMS. It's 67 degrees, 27 minutes, and 15 seconds. 13. Which of the following triangles contain an altitude? Is it A, B, C, or D? The answer is A. A contains an altitude. An altitude connects from one vertex to the opposite side of a triangle, and it meets that side at a right angle. So AD is an altitude for triangle A. That is for triangle in answer choice A. So this is the answer. B contains a perpendicular bisector. Now, like an altitude, a perpendicular bisector touches one side of the triangle at 90 degrees. However, it doesn't have to pass through vertex A. At the same time, the perpendicular bisector bisects the opposite side, BC, into two congruent parts, which means that D is the midpoint of BC, and BD and DC are equal to each other. So that's the perpendicular bisector. Now for answer choice C, BD is a median. A median bisects the opposite side into two congruent parts. So AD and DC are congruent, and D is the midpoint of AC. However, unlike a perpendicular bisector, it doesn't meet the opposite side at right angles. It simply bisects the opposite sides into two equal parts. Now, for answer choice D, it contains an angle bisector. DC is the angle bisector. It bisects angle C into two equal parts. So ACD is equal to BCD. So if ACD is 30, BCD is 30. They will have the same measure. So that's an angle bisector. And so that's it for this problem. So A is the correct answer. AD is the altitude. Number 14. The endpoints of a diameter of a circle are 1, 2, and 7, 10. Which of the following could be the equation of the circle? To write the equation of the circle in standard form, you need to use this formula. It's x minus h squared plus y minus k squared is equal to r squared. Now the center is h comma k, and r represents the radius of the circle. Now we have a circle, and one point is 1, 2, and the other point is 7, 10. Now these are the endpoints of the diameter of the circle. And the diameter of the circle passes through the center. In fact, the center is the midpoint of these 2 points, which are the endpoints of the diameter. So we need to use the midpoint formula to get the midpoint. That's going to give us the center. And then we can use the distance formula to get the radius of the circle. That is, we have to use the distance formula between the midpoint and any endpoint of the diameter. It can be 7, 10, or it can be 1, 2. But we have to use the midpoint in order to calculate the radius. So here is the midpoint formula. It's the average of the x values and the average of the y values. So what is the average of 1 and 7? The average of 1 and 7 is 4. 4 is the midpoint of 1 and 7. The midpoint of 2 and 10 is 6. But if you want to use the formula, here's what you need to do. So we have the points 1, 2 and 7, 10. So this is going to be x1, y1, and this is x2 and y2. So x1 is 1, x2 is 7. y1 is 2, y2 is 10. So 1 plus 7 is 8, and 2 plus 10 is 12. Now 8 divided by 2 is 4, 12 divided by 2 is 6. So this is the midpoint, which is also the center. So therefore the center of the circle is 4, 6. So we have the values of h and k now. H is 4, k is 6. Now let's calculate the radius. So we need to use the distance formula between the center of the circle and also any endpoint. I'm going to use this one, 1, 2. So here's the distance formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to call this x1 and y1, that's 1, 2. And 4 and 6, this is going to be x2 and y2. Now x2 is 4, x1 is 1, y2 is 6, y1 is 2. 4 minus 1 is 3, and 6 minus 2 is 4. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25, and the square root of 25 is 5. So the distance between the center and one of the endpoints of the diameter is 5, which means the radius of the circle is 5. So now let's use this formula. So h is 4, k is 6, and r is 5. So 5 squared, 5 times 5, that's 25. So this is the equation of the circle in its standard form, which means A is the right answer. Number 15. What is the area of the scalene triangle shown below? So we have a triangle with 3 sides, and the 3 sides are not the same, so it's not an equilateral triangle. The 3 sides are different. How can we calculate the area of this particular triangle? We need to use Heron's formula. So first, we need to calculate S, which is 1/2 of the perimeter. Now, lowercase a is across angle A, and side B is across angle B, and this is going to be side C. So S is going to be the perimeter A plus B plus C divided by 2. So it's half of the perimeter. A is 7, B is 8, C is 9. Now 7 plus 8 is 15. 15 plus 9 is 24. And 24 divided by 2 is 12. So S is equal to 12. That's the first step. Now the second step is to plug into this formula. So the area is going to be S times S minus A times S minus B times S minus C. So that's Heron's formula. Now S is 12. S minus A, that's going to be 12 minus 7. S minus B, that's 12 minus 8. And S minus C is 12 minus 9. Now 12 minus 7 is 5. 12 minus 8 is 4. And 12 minus 9 is 3. So this is what we have. Now let's see if we can simplify the square root. So 12, we can break that into 4 times 3. Now notice that we have 2 4s, which is 16. The square root of 16 is 4. So 2 4s will come out of the radical as 1 4. And notice that we have 2 3s. So that will come out the radical as a single 3. And so we have a 5 left over. 4 times 3 is 12. So it's going to be 12 square root 5. So this is the area of the triangle, which means answer choice A is the right answer. Number 16. The ratio of the length to the width of a rectangle is 8:5. If the area of the rectangle is 360, what is the perimeter of the rectangle? So let's begin by drawing a picture. And so let's say this is the length and this is the width. Now we know that the area is length times width. That's the area of a rectangle. And the area is 360. Now, if we could find the length and the width, we can calculate the perimeter. The perimeter is simply 2L plus 2W. In order to solve for two variables, we need two equations. The second equation we can get based on the ratio. So the ratio between the length and the width is 8:5. So therefore, L divided by W is 8/5. Now let's cross multiply. Or rather, let's solve for L. Let's multiply both sides by W. So L is 8W divided by 5. So now what I'm going to do is I'm going to replace L with that value. So 8W/5 times W. So now I have one equation in terms of one variable, so I can solve for W now. Let's multiply 5 to both sides so we can get rid of this fraction. 5 times 360, that's 1800. So 1800 is equal to 8 times W squared. Now let's divide both sides by 8. 1800 divided by 8 is 225. And now let's take the square root of both sides. The square root of 225 is 15. So W is 15. Now let's use this equation to calculate the value of L. So the area is 360 and W is 15. So L, the length of the rectangle, is 360 divided by 15, which is 24. So now that we have the length and the width, we can calculate the perimeter. So the length is 24 and the width of the rectangle is 15. The perimeter is the sum of all four sides. It's 2L plus 2W. So as we said before, L is 24 and W is 15. 2 times 24 is 48. 2 times 15 is 30. And 48 plus 30 is 78. So this is the perimeter of the rectangle. It's 78 units long. And that's it for this problem. Number 17. The length of the diagonal of a square is 10 inches. What is the area of the square? Well, let's see if we can come up with a relationship that relates the area of the square to its diagonal. So here is the diagonal of the square. Let's call it D. And let's call the side length X. Now the area of a square is simply length times width, or X times X. Now what's the relationship between X and D? Well, we can use the Pythagorean theorem since we have a right triangle. So let's say this is A, B, and C. So C squared is equal to A squared plus B squared. In this example, D is the same as C, and A and B are both equal to X. So 1x squared plus 1x squared is 2x squared. And then if we take the square root of both sides, we can see that D is going to be the square root of 2 times x. The square root of x squared is just x. So that's the relationship between the length of the diagonal and the side length. Now the area is equal to x squared. And if we go back a few steps, notice that we have d squared in terms of x squared. D squared is equal to 2x squared. Let's divide both sides by 2. So 2 over 2 is 1. So notice that 1/2 d squared is equal to x squared. And if x squared is equal to a, that means a is equal to half d squared. So this is the formula that we need. This is how we can calculate the area of a square if we're given the length of the diagonal. Now, this formula is actually very similar to the area for other shapes that we're going to go over later in this video. So make sure you know this equation. So the area is 1/2 d squared. So the length of the diagonal is 10, and 10 squared is 100, and half of 100 is 50. So the area is 50 square units, and that's the answer, which correlates to answer choice B. 18. In rhombus ABCD, BC is 10 and BE is 6. What is the area of the rhombus? Now, in the previous problem, we said that the area of a square is 1/2 d squared. It turns out that the area of a rhombus is very similar. However, the diagonal lengths of the rhombus are not the same. BD doesn't have to equal AC. So the area is going to be 1/2 d1 times d2, as opposed to 1/2 d times d, which is equivalent to that formula. So let's call this d1, that's BD, and AC is d2. So we need to calculate d1 and d2 before we can calculate the area of the rhombus. So in this problem, we're told that BC is 10 and BE is 6. So how can we figure out everything else that we need? It's important to know that the diagonals of a rhombus bisect each other at 90 degrees. So this is a 90-degree angle. The second thing is that all 4 sides of a rhombus are equal. So all of these are equal to 10. The next thing you need to know is that a rhombus bisects the diagonals. So what that means is that BE is congruent to ED and AE is congruent to EC. So E is the midpoint of BD and E is the midpoint of AC. So if BE is 6, ED is also 6. Now we need to calculate EC and AE as well. We have BE and ED. Let's focus on the right triangle BEC. We can see that BC is 10, BE is 6. What's EC? So we can use the Pythagorean theorem. C squared is equal to A squared plus B squared. C is the hypotenuse, which we'll call 10. And let's say that we're looking for A. A is EC. B is going to be BE. So B is 6. 10 squared is 100. 6 squared, or 6 times 6, is 36. And 100 minus 36 is 64. And then let's take the square root of both sides. The square root of 64 is 8. Now there are some special right triangle numbers that you want to commit to memory. So let me just get rid of some stuff. The first is the 3, 4, 5 right triangle. What this means is that 3 squared plus 4 squared is equal to 5 squared. It follows the Pythagorean theorem. 9 plus 16 is 25. So that's one special right triangle that you want to know from this point forward. The next one is the 5, 12, 13 triangle. And notice that this side is 8. If you multiply the 3, 4, 5 by 2, it gives you the 6, 8, 10 triangle. So any ratio or any multiple of that ratio will also work. So we have the 6, 8, 10 triangle in this example. Now some other numbers that you want to be familiar with is the 7, 24, 25 triangle. And there's also the 8, 15, 17 triangle. And there's the 9, 40, 41. And also the 11, 60, 61. But these 4 are the most common ones that you encounter. As for the rest, you could simply use the Pythagorean theorem to calculate the value of the missing side. But now let's finish this problem. So we have EC. EC is 8, which means that AE is also 8. Now the length of the first diagonal, D1, it's going to be 6 plus 6, which is 12. And the length of the second diagonal, D2, is going to be 8 plus 8, which is 16. And so now we can calculate the area of the rhombus. It's 1/2 D1 times D2. So D1 in this example is 12, D2 is 16. And half of 12 is 6. 6 times 16. Well, 6 times 10 is 60. 6 times 6 is 36. So 60 plus 36, that's 96. So the area of this particular rhombus is 96 square units, which means C is the right answer. Number 19. In kite ABCD, AD is 20, BE is 12, and BC is 13. What is the area of the kite? So like a rhombus, the area is the same. So this is going to be D1, that's BD, and AC is D2. The area is 1/2 D1 times D2. So let's focus on calculating the length of the two diagonals. So AD is 20, BE is 12, BC is 13. Now like a rhombus, the diagonals of a kite, they bisect each other at right angles. Now the second thing is that AB and AD are congruent, which means that AB is 20 as well. BC is congruent to DC, so DC is also 13. And BE is congruent to ED, which means ED is 12. Now we need to find the value of EC and AE. We already have D1. We can see that it's 12 plus 12, which is 24. So we need to calculate D2. Notice that we have a right triangle. So we can use the Pythagorean theorem to find the missing side. So we have 12 and 13. What do you think is the missing side? So from the last problem, recall that 5, 12, 13 are three numbers of a right triangle. So the missing side has to be 5. Now some other right triangles that we mentioned were the 7, 24, 25 triangle, the 3, 4, 5 triangle, and the 8, 15, 17 triangle. Which of these triangles do you think will be useful to find the missing side AE? Because this is also a right triangle. Is it the 7, 24, 25, the 3, 4, 5, the 8, 15, 17, or the 5, 12, 13? It turns out it's this one. If we multiply the 3, 4, 5 triangle by 4, notice what happens. So 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. Notice that we have two of the three sides. We have 12 and 20, which means the missing side has to be 16. And so that's why you want to know these special numbers, because it can save you a lot of time when solving these types of problems. So we have the 12, 16, 20 triangle. So now we can calculate D2, which is 16 plus 5, and that's 21. So the area is going to be 1/2 D1 times D2. So D1 is 24, D2 is 21. Now half of 24 is 12, so we're going to multiply 12 by 21. 12 times 21 is 252. And so that's the area of this particular kite. It's 252 square units, which means B is the answer. Number 20. What is the volume, surface area, and diagonal length of the rectangular prism shown below? So we have the length, which is 12. The width of the rectangular prism is 5, and the height is 4. To calculate the volume is simply length times width times height. So it's going to be 12 times 5 times 4. Now 12 times 5 is 60. 60 times 4 is 240. So it's going to be 240 cubic units, or units cube. Now what about the surface area? So we got to find the area of all 6 faces. So first let's find the area of the bottom face, which is length times width, and also the top face is also length times width. So the area for the bottom and the top, we could say it's 2 times LW. Next we have this side, the left side, and also the right side, which is basically the width times the height. So it's going to be 2WH. And then we have the area of the face on the back and the one on the front. which has the dimensions L times H. So it's going to be 2LH. So this is the formula to calculate the surface area of a rectangular prism. So let's go ahead and plug in the numbers. So L is 12, W is 5. And then WH, that's going to be 5 times 4, and then 2LH, 12 times 4. Now we said that 12 times 5 is 60, and 5 times 4 is 20, and 2 times 12 is 24. Now 2 times 60 is 120, 2 times 20 is 40, and 4 times 24. 4 times 20 is 80, 4 times 4 is 16, so that's 96. 120 plus 40 is 160. And now let's add 160 and 96. 6 and 9 is 15, 1 and 1 is 2. So the surface area is 256 square units. Now how can we calculate the length of the diagonal? So let's say if this is A, B, C, D, and this is E, F, G, H. We want to find the distance between point C and point F. How can we do that? Well, let's design a formula that's going to help us to get the answer. First, let's draw a line between point C and point G. So notice that, let's call this Z. Notice that we have a right triangle. So we can say that Z squared is equal to L squared plus W squared. Now, notice that we have another right triangle between Z, FG, and CF. So let's call CF D, the length of the diagonal. So D squared is going to equal H squared plus Z squared. Now, I know what Z squared is equal to. Z squared is L squared plus W squared, so I'm going to replace Z squared with that. So therefore, D squared is equal to H squared plus L squared plus W squared. So the length of the diagonal is the square root of L squared plus W squared plus H squared. And that's the formula that we need. So let's plug in. L is 12, W is 5, H is 4. 12 squared is 144, 5 squared is 25, and 4 squared is 16. Now 144 plus 16, that's 160, and 160 plus 25 is 185. So we have the square root of 185, which we cannot simplify, but as a decimal that's about 13.6 if you round it to the nearest tenth. So that's the answer. That's the diagonal length of the rectangular prism. 21. Triangle ABC is similar to triangle DEF. Using the figures shown below, what is the sum of x and y? Now, if the triangles are similar, that means that their sides are proportional. So we can set up a proportion. Now, this can help you. In the first fraction, I'm going to put the information for triangle 1, and for the second fraction, triangle 2. Now, let's say the top part is going to be referenced to the long side, and the bottom part, the short side. So the long side of triangle 1, that's BC, which is 12. The short side of triangle 1 is AB, which is 8. The long side of triangle 2, that's X. EF has to correspond to BC. And the short side of triangle 2 is DE, which is 20. So now let's solve for X. Let's cross multiply. So this is going to be 8X. That's equal to 12 times 20, which is 240. And now let's divide both sides by 8. 240 divided by 8 is 30. So X is equal to that. Now let's talk about how you can confirm that 30 is the correct answer. Let's divide 20 by 8. 20 divided by 8 is 2.5. So 2.5 is the scale factor. If you take 8 and multiply it by 2.5, you get 20. So therefore, if we take 12 and multiply it by 2.5, we should get the same answer. And 12 times 2.5 is 30. So that's a quick way to confirm if you have the right answer. Now, let's calculate the value of y. Whenever two triangles are similar to each other, the angles are congruent. So angle A and angle D are congruent. Angle B and angle E, they're both equal, they're both 90. And then the other two angles, angle C and angle F, these two are congruent as well. So therefore, we can set 40 equal to 4y plus 12. So let's subtract both sides by 12. 40 minus 12 is 28. So 28 is equal to 4y. And now let's divide by 4. So y is 7. So now we can calculate the sum of x and y. It's 30 plus 7, or 37. So therefore, D is the right answer. Number 22. B is the midpoint of AC, and D is the midpoint of CE. If BD is 4x minus 8, and AE is 5x minus 1, what is the length of segment BD? So we're told that B is the midpoint of AC. That means that AB and BC are the same. And if D is the midpoint of CE, CD and DE are congruent. When we have this situation, it turns out that BD is 1/2 of segment AE. Now we know that BD is 4x minus 8, and AE is 5x minus 1. So if we can calculate the value of x, we can determine the length of segment BD. So let's multiply both sides by 2 to get rid of the fraction. 1/2 times 2 is 1. Now let's distribute the 2. 2 times 4x is 8x. 2 times negative 8 is negative 16. And so that's going to be equal to 5x minus 1. Now let's subtract both sides by 5x. And let's add 16 on both sides. 8x minus 5x is 3x. Negative 1 plus 16 is 15. Now let's divide both sides by 3. 15 divided by 3 is 5. So x is equal to 5. And BD, we know it's 4x minus 8. So let's replace x with 5. 4 times 5 is 20. And 20 minus 8 is 12. So this is the length of segment BD. It's 12 units long. So C is the right answer for this problem. 23. What is the value of x in the trapezoid shown below? Now we can see that E is the midpoint of AB and F is the midpoint of CD, since BE and AE are congruent and CF equals DF. Now when that happens, this number 24, EF, is the average of BC and AD. So therefore 24 is going to be 1/2 the value of x and 18. A quick way to determine the value of x is to look at the difference between 18 and 24. The difference is 6. So to go from BC to EF, you have to add 6. And to go from EF to x or AD, you have to add another 6. So x is going to equal 30. But let's use this equation to get the answer. So first I'm going to multiply both sides by 2 to get rid of the 1/2. 2 times 24 is 48. Next, I'm going to subtract both sides by 18. 48 minus 18 is 30. So x is equal to 30, which means that C is the right answer. 24. What is the measure of angle D in quadrilateral ABCD? So first, we need to determine the sum of all of the interior angles of a quadrilateral. A quadrilateral is basically a four-sided figure. And to determine the sum of the interior angles, we can use this formula. So a quadrilateral has four sides, so n is 4. 4 minus 2 is 2. So the sum of the interior angles has to be 360. So therefore, we could say that angle A, which is 5x plus 10, plus angle B, which is 110, plus the measure of angle C, that's x squared minus 44, plus the measure of angle D, which is 7x minus 4. All of that has to add to 360. So now let's calculate the value of x. So let's write this in standard form. We have x squared, and let's combine the like terms. 5x and 7x adds up to 12x. And then we have 10 plus 110, that's 120, minus 44, that's 76, minus 4, that's 72. And that's equal to 360. Now let's subtract 72 by 360. And so that's going to be negative 288. So that's what we now have. Now, in order to solve for x, we need to factor. So what two numbers multiplies to negative 288, but add to the middle coefficient, positive 12? Well, let's make a list. If we divide this by 4, this will give us 72. One of these has to be negative. And these two numbers, they don't add up to 12. So let's try a bigger number. Let's try 8. (288) divided by 8 is 36. So that's not going to work. Let's try 12. Negative 288 divided by negative 12 is 24. Now this works. These two numbers add up to 12. So to factor it, it's going to be x minus 12 times x plus 24. And that's equal to 0. Now let's set each factor equal to 0. So we get two possible answers for x. X could be positive 12 or negative 24. Now we can't use this answer because angle A and D will be negative, which is not possible. So therefore x has to be 12. So now angle D, which is equal to 7x minus 4, that's going to be 7 times 12 minus 4. Now 7 times 10 is 70. 7 times 2 is 14. So 7 times 12 is 84. And 84 minus 4 is 80. So this is the measure of angle D. It's 80 degrees. Therefore D is the right answer choice. 25. What is the value of x in the figure shown below? So we can see that DE is equal to x. AE is 16 and AB is 34. Now if AB is 34 and AE is 16, EB has to be the difference between 16 and 34. So 34 minus 16, that's 18. Now we have DC, which is 36. And we have DE, but we don't have EC. So we got to calculate EC. So DE plus EC has to equal the total segment DC. DE is x. We're looking for EC. And DC is 36. So therefore we can say that EC is 36 minus x if we subtract both sides by x. Now, in order to calculate the value of x, we need to use something called the chord power theorem. And the formula for that is AB is equal to CD. So let me put this in a different color. This would be A, this would be B, this is C, and this is D. So A times B, that's going to be 16 times 18. C times D, that's 36 minus x times x. Now 16 times 18, that's 288. And then 36 times x is 36x. And then negative x times x is negative x squared. Now I'm going to take everything from the right side, move it to the left. So on the left side, this is going to be positive x squared. And this will be negative 36x. And this will remain positive 288. So once again, I need to factor this expression. So what two numbers multiply to 288 but add to negative 36? This is going to be 12 and 24, but both have to be negative. Negative 12 times negative 24 is positive 288, but they add up to negative 36. So it's going to be x minus 12 and x minus 24, which means x can be equal to 12 or 24. It really doesn't matter. 16 times 18, that's going to equal x, which is 12, and then 36 minus x, or 36 minus 12 is 24. Or if you do it this way, if x is 24, then 36 minus 24 is 12. So either way, it will still work. Now, since 24 is not listed as one of the answers, we're going to go with 12. So therefore, D is the right answer in this problem. 26. Given the points A, B, and C on the triangle shown below, what is the slope of altitude BD? Now the first thing we need to know is that an altitude is perpendicular to the side that it interacts with, that is opposite to the vertex from which it comes from. Now, you need to be familiar with the slope of perpendicular lines. So consider these two lines, line L and line K. And let's say that these lines are perpendicular to each other. And let's say if you know the slope of line L, let's say it's 2 over 3. What is the slope of line K, which is perpendicular to line L? To find the slope, you need to flip the fraction and change the sign from positive to negative, or vice versa. So it's the negative reciprocal of the other line. Now, to find the slope of BD, we need to find the slope of the line that's perpendicular to it, that is AC. And we could find the slope of this line because we have 2 points on that line. And so to calculate the slope between 2 points, which would be the slope of AC, we can use this formula. y2 minus y1 divided by x2 minus x1. So this is going to be x1, that's y1, and this is x2 and y2. So y2 is 9, y1 is 3. x2 is 4, x1 is 2. 9 minus 3 is 6. 4 minus 2 is 2. 6 over 2 is 3. So the slope of segment AC is 3, or 3 over 1. So the slope of BD, which is perpendicular to AC, it has to be 1 over 3 with a negative sign. So it's negative 1/3, which means that D is the right answer. Number 27. What is the difference between the values of x and y in the figure below? Now we're given that arc AE, the measure, is 110 and the measure of arc BD is 50. So with this information, how can we calculate the difference between x and y? Well, let's break up this problem into 2 parts. The first part is a chord angle problem. So this is A, E, B, D, and F. So arc AE is 110, arc BD is 50, and we need to calculate x. It turns out that x is the average of 50 and 110. So it's 1/2, 50 plus 110. 110 plus 50 is 160, and half of 160 is 80. So as you can see, 80 is the angle between 50 and 110. So that's the value of x. Now let's calculate the value of y. So we have 2 secants passing through the circle. A secant is a line that touches the circle at 2 points. So we have secant AC and secant EC. Now AE is still 110, BD is still 50. Now to calculate angle Y, it turns out that it's going to be 1/2 the difference between the two arcs. So the difference between them is going to be 110 minus 50, which is 60. So Y is going to be half of 60, which is 30. So that's the measure of angle Y, which is the same as angle C. Now the difference between X and Y, 80 minus 30, is 50. So C is the right answer. 28. What is the length of DC in the figure below? So what do we need to do to this problem? We need to use the secant tangent power theorem. The formula for that is t squared is equal to E times S. T represents the tangent segment, and keep in mind a tangent line touches the circle only at one point. A secant line touches it at 2 points. E is the exterior portion of the secant segment, so E is BC, and S is the secant itself, which is AC. So T is equal to X, and the exterior part is 9. The secant is the sum of AB and BC, so it's 7 plus 9, which is 16. Now let's multiply 9 times 16. 9 times 16 is 144, and so that's equal to x squared. So all we have to do at this point is take the square root of both sides. So the square root of 144 is 12. So therefore C is the right answer. 29. The height and volume of a cone are 15 inches and 320 pi cubic inches respectively. What is the total surface area of the cone? So let's begin with a picture. So here's the cone. This is the radius of the cone. Here we have the height of the cone, and this is the slant height, and this is the right angle. Now the surface area, the total surface area, is going to be the area of the base plus the lateral area. So the area of the base is basically the area of the circle on top, which is pi r squared. That's the area of a circle. Now the lateral area, LA, that's going to be the area around the cone, basically that wraps it around. And it turns out that it's simply pi times r times L. The lateral area, if you want to determine it, it's 1/2 the perimeter times the slant height. The perimeter of a circle is basically the circumference of a circle, which is 2 pi r. So half of 2 pi is just pi, so it's pi times r times L. So that's the formula that you need to calculate the surface area of a cone. Now let's go ahead and finish this problem. So let's write down what we have. So we know that the height is 15 inches. The volume is 320 pi cubic inches. What we need is the radius and the slant height. So the volume of a cone is 1/3 times the volume of a cylinder, which is pi r squared times the height. Now we don't have r, h is 15, and volume is 320 pi. So we could cancel pi. 1/3 of 15 is 5. So 320 is equal to 5r squared. Now let's divide both sides by 5. 320 divided by 5 is 64. So now we need to take the square root of both sides. The square root of 64 is 8. So the radius is 8 cubic inches. Now let's calculate the slant height. So let's focus on the right triangle that we have. H is 15, R is 8. So what's the missing side? Notice that this is the 8, 15, 17 triangle. So now we have the slant height, which is 17 inches. So the surface area is going to be pi r squared, where r is 8, plus pi rl, where l is 17. 8 squared is 64. 8 times 17 is 136. And 64 plus 136 is 200. So the surface area of this particular cone is 200 pi square inches. Number 30. CD is perpendicular to AB. If AB is 7x minus 5 and AD is 3x minus 1, what is the length of segment CD if the radius of circle C is 10? So we know that C is the center of the circle and CD is perpendicular to AB. Now, whenever you have a segment that extends from the center of the circle and it's perpendicular to a chord, then the chord is going to be bisected into two congruent parts. So that means that AD is congruent to DB, which means D is the midpoint of chord AB. So what can we do with this information? Well, first, we need to calculate the value of x. Let's say if AD is 5, DB is 5, and AB has to be 10. So therefore, AD is 1/2 of AB. 5 is 1/2 of 10. So AD is 1/2 of AB. Now, AD is 3x minus 1, and AB is 7x minus 5. Let's multiply both sides by 2. So 1/2 times 2 is 1. So we're just going to have 7x minus 5 on the right side. On the left, it's going to be 6x minus 2. Now, let's subtract both sides by 6x, and let's add 5 to both sides. Negative 2 plus 5 is 3. 7 minus 6 is 1. So x is equal to 3. Now that we have the value of x, we can calculate AD. Now, AD is 3x minus 1. And so it's going to be 3 times 3 minus 1. 3 times 3 is 9. 9 minus 1 is 8. So AD is 8, which means DB is also 8. And AB has to be 16. Now let's draw a line from the center to point A. So anytime you draw a line segment between the center of the circle and any point on the circle, that represents the radius of the circle. So if AC is the radius of the circle, then AC is 10. And notice what type of triangle we have. This is related to the 3, 4, 5 triangle. If we multiply it by 2, this will give us the 6, 8, 10 triangle. So the missing side is 6, which is CD. And so that's how we can calculate the length of segment CD. It's equal to 6, which means that B is the answer. Number 31. The arithmetic mean and geometric mean of two numbers are 35 and 28 respectively. What are the two numbers? So first, let's talk about the arithmetic mean and geometric mean. For example, what exactly is it? The arithmetic mean is related to an arithmetic sequence. So for example, 4, 7, 10, 13, 16 forms an arithmetic sequence. There's a common difference of 3 between each numbers. So if I want to find the arithmetic mean of 4 and 10, it's going to be the middle number of the sequence. And the formula to calculate the arithmetic mean, it's going to be A plus B divided by 2. So it's going to be 4 plus 10 over 2. Basically, it's the average. So 14 over 2 is 7. Now, let's say if I want to find the arithmetic mean between 4 and 16, it's going to give me the middle number 10. So using the same formula, 4 plus 16 divided by 2, that's equal to 20 over 2, which is 10. So that's the basic idea behind the arithmetic mean. Now, as for the geometric mean, it's very similar, but let's write a geometric sequence. So let's start with 4, and I'm going to multiply by 2. 8, 16, 32, 64. So to get to the next number, you need to multiply by 2. So that's the geometric sequence. We have a common ratio of 2. So the geometric mean between 4 and 16 is 8. And here's the formula to calculate it. It's the square root of AB. So the square root of 4 times 16. Now 4 times 16 is 64. And the square root of 64 is 8. Now let's say if I want to find the geometric mean between 4 and 64. It's going to be 16. Now what's 4 times 64? 4 times 60 is 240. 4 times 4 is 16. So 240 plus 16 is 256. And the square root of 256 is 16. Now granted, you could have done it this way. You could separate 4 and 64. The square root of 4 is 2. The square root of 64 is 8. 2 times 8 is 16. And this shouldn't be square root 16. That's simply 16. So as you can see, the geometric mean is 16. So now you understand what the geometric mean and arithmetic mean represent. Let's focus on answering this problem. So the arithmetic mean, which I'm going to call A, is 35. The geometric mean is 28. What are the two numbers? So the arithmetic mean is going to be the two numbers, A plus B divided by 2. And the geometric mean is going to be the square root of the product of those two numbers. So we have two equations and two variables. How can we solve for these two variables? Well, let's focus on this equation. I'm going to isolate A. So let's multiply both sides by 2. 35 times 2 is 70. So A plus B is equal to 70. Subtracting both sides by B, I have that 70 minus B is equal to A. Now on the right side, I'm going to get rid of the square root by taking the square of both sides. So 28 squared, or 28 times 28, that's 784. And these two will cancel, so I'm just going to have A times B. Now I'm going to replace A with 70 minus B. So now I could solve for B. So I'm going to distribute this B. So it's going to be 70B minus B squared. So I'm going to take everything from the right side and move it to the left side. So on the left it's going to be positive B squared and negative 70B. Now this is going to remain on the left, so it's going to stay positive 784. Now I need to factor the expression. So I need to find two numbers that multiply to positive 784 but add to negative 70. So let's start with 4. 784 divided by 4 is 196. That's not going to add to negative 70. Now let's try 8. 784 divided by 8 is 98. So that's not going to work. Let's try 16. This is going to be 49. 49 plus 16 is 65, so that's close. Now, 49 contains two 7s, so I know that 784 is divisible by 7, and 16 can be broken into 8 and 2, 4 and 2, and 2 and 2. So I need to try a number that's less than 16. So I'm going to try 7 times 2, which is 14. 784 divided by 14 is 56. Notice that 14 plus 56 adds up to 70. But I need to make it negative. So to factor this expression, it's going to be B minus 14 times B minus 56. So now we have two possible answers for B. So let's set each factor equal to 0. So B can be equal to 14, or it could be equal to 56. And recall that earlier we said that A plus B is equal to 70. So if B is 14, 70 minus 14 is 56. And if B is 56, A is 14. So either way you see it, the two numbers are 14 and 56. And so that's the answer. Number 32. Calculate the lengths of segments AC, CB, and CD in the figure below. So what we have in this problem is an altitude on the hypotenuse. So we have altitude CD, and it's on the hypotenuse AB of triangle ACB. Whenever you have a triangle like this, there are some equations that you want to be familiar with. But first, let's label the variables that we need to be familiar with. So AC, I'm going to call it lowercase b because it's opposite to angle B. CB, I'm going to call it lowercase a. It's opposite to angle A. And the altitude CD, I'm going to call it h. It's the height of the triangle. That is triangle ACB. So we need to calculate A, B, and H in this problem. Now I'm going to call 12, or AD, x. DB is y. And the sum of x and y is c because that's opposite to angle C. Now to calculate h, you need to know that h is the geometric mean of x and y. A is the geometric mean of y and C. And B is the geometric mean of x and C, since x is closest to B. So those are the formulas that you need to know to calculate A, B, and H. So let's start with H. So x is 12 and y is 6. So it's the square root of 72. Now 72 is 36 times 2. And the square root of 36 is 6. So h, which is segment CD, that's 6 square root 2. So that's one of the answers that we need. Now let's calculate A, segment CB. So A is going to be the square root of y times C. So y is 6, and C is 12 plus 6, or 18. Now, 18 is 6 times 3. And the square root of 6 times the square root of 6 is 6. So A, which is segment CB, that's 6 square root 3. Now let's move on to the last part. And that's B. So x is 12 and C is 18. So 12 is 6 times 2. 18 is 6 times 3. And I'm going to multiply 2 and 3. So there's 3 6's in this example. 6 times 6 is 6. So B is going to be 6 square root 6. And so that's segment AC. And so that's it for this video. So make sure you know that these 3 formulas are basically the geometric means of these values. Now there are some other equations that are useful if you ever need them. So if you focus on the large triangle, that is triangle ACB, it's a right triangle. So therefore you can use the Pythagorean theorem. So you could say that c squared is equal to a squared plus b squared. So that's another formula that you could use if you need to find a missing side. Now notice that we have a right triangle here as well, between b, h, and x. So therefore we could say that b squared is equal to h squared plus x squared. And there's also another right triangle here. So we can also say that a squared is h squared plus y squared. And also we know that c is the sum of x and y, as you can see. So those are 7 formulas that you can use for this particular situation. 33. What is the area of the parallelogram shown below? Now, this equation, or rather this problem, is not that bad. You simply need to know this equation. The area of a parallelogram is just the base times the height. So the base is 10, the height is 15. So it's 10 times 15, which is 150 square units. And so that's a simple way to calculate the area of a parallelogram. 34. What is the sum of R and Z in parallelogram ABCD? So the first thing that we need to know is that opposite sides are congruent in a parallelogram. So we could say that 24 is equal to 3x plus 9. This will help us to calculate x. And we can also say that 30 is equal to 4y plus 2. So let's subtract both sides by 9. 24 minus 9, that's 15. And we can bring down to 3x. And now let's divide both sides by 3. So 15 divided by 3, that tells us that x is equal to 5. Now, in this equation, let's subtract both sides by 2. So 30 minus 2 is 28. And then let's divide by 4. So 28 divided by 4 is 7. So y is equal to 7. So now that we have x and y, we can calculate r and z. The next thing you need to know is that the diagonals, they bisect each other. So r is equal to 5x plus 2, and z is equal to 3y. Now we have the value of x. X is 5. 5 times 5 is 25. And 25 plus 2 is 27. So r is equal to 27. Now z is equal to 3y. And y is 7. 3 times 7 is 21. So z is equal to 21. And now our goal is to calculate the sum of z plus r. So that's 21 plus 27, which is 48. So that's the answer, which is answer choice E. 35. What is the difference between the values of r and s in parallelogram ABCD? So in a parallelogram, you need to know that the opposite angles are congruent. So A equals C, B is equal to D. Now, B and D won't be helpful because we have two different variables. However, we need to focus on A and C because they both contain the same variable x. So the measure of angle A is equal to the measure of angle C. So angle A has a measure of 13x, and the measure of angle C is 10x plus 15. Let's subtract both sides by 10x. 13x minus 10x is 3x. So 3x is equal to 15. And if we divide by 3, we can see that x is equal to 5. So now that we have the value of x, we can determine the measure of angle A and C. So the measure of angle A is 13x, which is 13 times 5, and that's 65 degrees. So angle A is 65 degrees, and angle C, which equals angle A, must also be 65. Now, angle C and angle D, consecutive angles in a parallelogram, are supplementary. So the measure of angle C plus the measure of angle D, they add up to 180. So C is 65, and we're looking for D. So D is going to be 180 minus 65, which is 115. So if angle D is 115, angle B is also 115. So now we can calculate the values of R and S. So 115, which is angle B, that's equal to 12R plus 19. So let's subtract both sides by 19. 115 minus 19 is 96, and that's equal to 12R. 96 divided by 12 is 8, so R is equal to 8. Now angle D is 11S minus 6, and that's also equal to 115. So let's add 6 to both sides. 115 plus 6 is 121. And if we divide both sides by 11, 121 divided by 11 is 11. So we have the values of S and R. And our goal is to calculate the difference between those two values. So S minus R, that's 11 minus 8. The difference is 3, which means that C is the answer. And that's it for that problem. 36. What is the value of H in the figure below? Now we have a right triangle, and in order to calculate H, you need to be familiar with something called SOHCAHTOA. The so part tells us that the sine of the angle is equal to the opposite side divided by the hypotenuse. Ca tells us that cosine of the angle is the adjacent side over the hypotenuse. And toa, tangent, tells us that tangent theta is going to be the opposite side over the adjacent side. So the hypotenuse is the longest side of the triangle. It's across the box. Relative to the 25-degree angle, 500 is adjacent or next to it, and opposite to the angle is h. So therefore, since tangent is opposite over adjacent, we want to use that particular trig function. So tangent of the angle, 25 degrees, is equal to the opposite side, which is h, divided by the adjacent side, 500. So let's cross multiply. This is going to be 1 times h, and that's equal to 500 times tangent of 25 degrees. Make sure your calculator is in degree mode. So 500 times tan 25, that's equal to 233, rounded to the nearest whole number. And so that's the answer. 37. Calculate the area of the regular hexagon shown below. The area of a regular polygon is 1/2 the apothem times the perimeter. Now, if it's a regular hexagon, that means all sides are the same. So each side is 20. So the perimeter is going to be n times the length of each side. So the 6 sides, and each with a side length of 20. So the perimeter is 6 times 20, or 120. So now we need to calculate the apothem, which is the distance between the center of the circle and the midpoint of any side of the circle. So that's the apothem. Between the center of the circle and the vertex, or any vertex, that's the radius of the circle. I mean, not the circle, but the polygon. So how can we calculate A? So if we have, let's say, a hexagon, and we split it 6 ways, what do you think the angle is for these 6 pieces that I drew? A full circle is 360. And if you take 360 and divide it by 6, that means that each of these angles represent 60 degrees. So therefore, this angle is 60, which means the angle inside this triangle is half of 60, which is 30, which means that is 60. So let's focus on this right triangle, this 30, 60, 90 triangle. Our goal is to calculate A. Now this side length is 20, which means that the base of this small triangle is half of 20, which is 10. So how can we calculate A if this side is 10? Now you need to be familiar with the 30, 60, 90 reference triangle. Across the 90 is 2, across the 30 is 1/2 of the hypotenuse, and across the 60 is whatever this number is times the square root of 3. So if this is 10, this number is going to be 10 times the square root of 3. And so that tells us the value of A. So now that we have A, and we also have the perimeter, we can now calculate the area using this formula. So it's going to be 1/2 multiplied by the apothem, which is 10 square root 3, times the perimeter, which is 120. Now 10 times 120, that's 1200. And half of 1200 is 600. So the area is going to be 600 times the square root of 3. And that's the answer. 38. Calculate the total surface area of the figure shown below. So what we have here is a triangular prism. And we have a right triangle, so the hypotenuse has to be 5. It's a 3, 4, 5 right triangle. Now the total surface area of a prism, or a triangular prism, it's going to be the area of the base plus the lateral area. So the area of the base represents the triangles, the triangle on the left and the one on the right. Now the area of a triangle is base times height, or 1/2 base times height. but there's two triangles, so we're going to multiply that by 2. The lateral area is the perimeter of the triangle times the height of the prism. So we could cancel 2 and 1/2. So the total surface area is going to be the base of the triangle times the height of the triangle times the perimeter of the triangle multiplied by the height of the prism, which is 10. So the base of the triangle is 3, the height of the triangle is 4. The perimeter of the triangle is going to be 3 plus 4 plus 5, which is 12. And the height of the prism, that's 10. 3 times 4 is 12. 12 times 10 is 120. And so 12 plus 120 is 132. So the total surface area is 132 square units. 39. What is the measure of arc EF? Now we're given angle B, so that's 40 degrees, and arc DF is 120. How can we use this information to calculate the measure of arc EF? Now let's say if you have a circle and you have a point, and let's draw 2 tangent segments that extend to that point. So let's call this A, B, and C. So B is the common endpoint of 2 tangent segments. And keep in mind, a tangent, or a tangent segment, touches the circle at only one point. You need to know that these 2 tangents are congruent, and also angle B, let's say if it's 50, and arc AC, which is going to be 130, these 2 are supplementary. So knowing that, if angle B is 40, arc DE has to be 180 minus 40, which is 140. Now, if arc DF is 120, angle A has to be 180 minus 120, which is 60. Now, if B is 40 and A is 60, we know that C has to be 180 minus 60 minus 40. 180 minus 60 is 120. 120 minus 40 is 80. So angle C is 80 degrees. Now if angle C is 80, arc EF has to be 180 minus 80, which is 100. Now we can check our answers. So DE is 140, DF is 120, and EF is 100. These 3 have to add up to 360. 120 plus 140 plus 100 does add up to 360, which is a full circle. So that's how you can quickly check the work to see if you did it correctly. So the measure of arc EF is 100 degrees. And that's the answer for this problem. 40. What is the sum of the radii of the 3 circles shown below? So we're given AB. AB is 13. And BC is 12. And we're given also AC, which is 15. So how can we find the answer that we need? Now notice that this is the radius of circle A. But first, let's call this point point D, this point here point E, and point F. Now these 2 are equal to each other because that represents the radius of circle A. These 2 parts are congruent, that represents the radius of circle B. And these 2 parts are congruent, which represents the radius of circle C. So let's call the radius of circle A x. So this is x as well. Now, if AD is x, what's BD? BD has to be the total length minus x, or 13 minus x. Now, FC has to be 15 minus x, because when you add these 2, you need to get 15. Now, because DB and BE are the same, BE is also 13 minus x. And FC and CE are also equal to each other, so CE is 15 minus x. Now, we could say that CE, which is this segment, plus BE, which is that segment, that's equal to the total segment CB, or BC. Now, CE is 15 minus x, BE is 13 minus x, and BC is 12. So now we can calculate the value of x. So let's combine like terms. 15 plus 13 is 28, and negative x minus x is negative 2x. So let's subtract both sides by 28. 12 minus 28 is negative 16. And now let's divide both sides by negative 2. So x is equal to 8. So now we can calculate the radius of each circle. So let's start with the radius of circle A. Notice that it's equal to x, and x is 8. So RA is equal to 8. Now for circle B, the radius is 13 minus x. So this is going to be 13 minus 8, which is 5. Now let's move on to circle C. For circle C, it's 15 minus x, which is 15 minus 8, and that's 7. So now we have the radius of all three circles. So to calculate the sum, it's going to be 8 plus 7 plus 5. Now 8 plus 7 is 15. 15 plus 5 is 20. So the sum of the radii of all the circles is 20 units. And that's it. So that's it for this video. Thanks for watching. And if you want more example problems on geometry, like the ones you've seen in this video, just check out my geometry playlist, and you could find a specific topic that you need help with. Thanks again for watching.